Yeah, so what I wanted to talk about today was cybersecurity in industrial control systems. So this is really a talk where, before I switch to presentation mode, just wanted to show you. So there was an executive order from a month ago, February actually, where it has been recognized that our nation's critical infrastructure is at risk. And this is something that the US government is working with operators of various critical infrastructure like refineries, power stations, and also companies like us who provide control systems to secure these facilities. So this is going to be an ongoing effort where we will be sharing information, where we're going to share information with the government to identify the critical risks. So what I wanted to talk to you about today was the current state of cybersecurity in industrial control systems. So in a sense, this is really more of a view of what's out there as opposed to maybe cutting edge research. So just to set the context, a typical distributed control system, and you're working in this area, so you'll be familiar based on the Purview model. So we traditionally have the various levels, and the DCSs are all sort of following this model, where we have safety critical systems, your field instrumentation, your process control, your supervisory control, and your manufacturing operation. So that set that we refer to as a process control system as isolated from the MES and the enterprise network. So this is an example of a system, this Honeywell Experience system. In general, security is controlled through firewalls at different levels. You have pretty much a hard core, but in general with DCS in the past, traditionally it's been a soft squishy setup. So once you get past the perimeter, there's always been the concerns about security. So that approach worked reasonably well when what we were concerned about were viruses on the IT network. Now, I didn't want those viruses or those attacks to make their way into the process control network. But now we're starting to see targeted cyber attacks, and you would have seen over the last few years, targeted attacks against infrastructure. Like Stuxnet was an example, Flame, and so on, where there is more concern that just having this hardened perimeter is insufficient. But at the same time, as we look at how we address these security challenges, we also have to recognize what our customers are worried about. Right? Our customers are worried about, because we talked about the targeted cyber attacks, a lot of our customers come from a world where process control systems, they're still running plants from process control systems that were released 20 years ago or 30 years ago, proprietary systems. Now we are reaching component obsolescence and they want to migrate forward. They're totally unprepared for open systems. Right? They're unprepared to put PCs on their process control network. They don't have the discipline necessarily to follow all the practices that are required in order to secure their network. They don't have the experience, and they certainly don't have sufficient resources. Now, maybe big companies like ExxonMobil may have dedicated process control IT or industrial IT departments, but that's not the case with a lot of operators. So if you really look at where the spectrum of industrial systems are in terms of cybersecurity, there's really a broad range. You have some that are very secure, and then at the other end you have systems that are totally unprepared. They really want to have a system that they can plug in and that's secure from the word go. You don't necessarily want to provide a solution that requires a lot of configuration. They're also very uncomfortable with the pace of technology churn. They're used to putting in systems and they run for 20 or 30 years. And now we have obsolescence in 7 years, 8 years, right? I mean, Dell PCI bus goes out of, you can't use it anymore. I mean, you have Microsoft coming up with new versions of operating systems. Now, yeah, it's not just the embedded devices, it's all of those PCs on that network that they're concerned about. We're also likely to see more regulation. So we saw the executive order there. That's really intended to be voluntary to start with, but there is a strong lobby that wants to hold the operators and control system vendors liable if there is a security attack on an infrastructure, right? So obviously that's something that we have to be prepared for. But security has traditionally been an afterthought to the operators, because for them what's important is uptime. Their plant has to run 24/7. Every Tuesday, once a month, my PC gets Microsoft updates and it reboots. Well, when you have a control system, regardless of redundancy, you have 40 operator stations and you have servers and application nodes. Having to deal with something like that on a regular basis, it's not something that a plant operator wants to do, right? I mean, they want to have their system running 24/7 without having to deal with patches and so on. So those are some of the challenges that we have. At the same time, air gapping or separating the process control network from the business network is not an option, because there's more and more data that's available from process control systems for applications like asset management or for process optimization, or to understand how the plant is running. And so there's the need for the tighter linkage, but at the same time without forgetting about security. So I just want to quickly look at what are some of the things that we do today in control systems, and then finally look at the future and see how we see a control system in the future. So right now it's the typical things that you see in the IT, in a standard corporate network. You see that in the industrial network as well. Antivirus, you have patch management both because you have vendor software as well as operating system software from open systems and commodity operating systems. We also do whitelisting, application whitelisting. So this is where it's the opposite of antivirus, where we say only approved applications can run. Intrusion detection and prevention systems, so that you can detect when there is an attack occurring. There's Windows lockdown, you don't USB cards. I mean, I was at a customer site where they refuse to use Windows because they say, I can't control an operator who can bring in a movie and watch a movie by putting a USB card in there. Well, using Unix systems there sometimes is really just security by obfuscation. And of course, if all else fails, there's disaster recovery. So what are some of the areas that we're looking at right now? Authenticated and encrypted communication is something that's been there by default on wireless systems, but we're looking at it on wired systems as well. So using certificate-based, where you have device whitelisting. A device is not allowed to join the control network unless it exchanges a certificate. We have strict least privilege both for people, applications, and for devices. So someone can't introduce a rogue device into the network and generate a problem on the network. So it's running short of time, so I just want to have a couple of more slides. So these are some of the current trends that we see in industrial systems, and any cybersecurity solution needs to handle this. We see virtualization. Customers are finally accepting the use of virtualization on industrial plants. Mobile solutions, people are used to tablets. They want to be able to have access not just from their operator stations but from elsewhere. Wireless, of course, as you know, is a big trend. Better collaboration tools. You can have a collaboration where someone wants to look at the state of an entire pipeline, and they want to bring in video data, and they want to interface with not just the control data but also data from other sites. So it's a mix of corporate data and process data. And of course, remote operations. We see that with some of our unconventional oil and gas finds, that systems are out there in the middle of nowhere. You can't really go there and manage the system. It has to be done remotely. So where do we see some of the control systems of the future? And here is an area that, maybe these are areas for discussion and we can discuss after the meeting. But where does cloud computing fit in and big data? So now that we have Ethernet everywhere, right down to the field network level, and we have wireless, we have so much data that we can get from our browse devices. So how we make use of that, and what sort of applications around asset management or around predictive maintenance can we do? What sort of analysis, business analytics can we apply here with cloud computing? Can we think of a zero footprint control system where we eliminate all of these problems with these middleware nodes with Microsoft PCs, push the services up to the cloud, and or appliances down below. It's just a mix of appliances and services, and you don't have to worry about managing anything in between. Is that something that's a feasible approach? I mean, these are some of the areas that we're starting to look at. Embedded virtualization. This is an area where, well, if all your I/O data is equally available to all your control elements, can you think of your control elements just as an embedded virtual system where you can just add resources so that you can do more control? And that's something that we can look at. And then of course wireless with wireless sensors. I just want to point out an example of a university-industry collaboration that's going on for the last couple of years is ESOP, the Architecture for Service-Oriented Process. This is something that's in the EU industry and university participation to look at if you can have a system of systems approach where you have multiple DCSs, it's all service-oriented, and what sort of SOA infrastructure would you need in order to be able to do the controlling. So I had to go through that pretty quickly, sorry about that. But if you have any questions after this, specifically around control systems of the future, that's an area that we'd like to